Hi, Xander. We're just waiting for a few people to join us. I will be going through as much as I possibly can, but I've popped the topics on the board. Okay, we should be able to start shortly. Hi, Osama.
Hello.
Hello. Oh, I'm going to ask you to pop your microphone off, lovely, because we have a number of participants. Thank you very much. Okay, so we've got our topics up on the board, and we're just waiting for everybody to have logged themselves in. We have a few more, and then I'm going to go through these topics as quickly as possible, but you will have access to the video and also all of the notes. Okay, and I'm going to attempt to join in as well so I can see the chat. Okay, so whilst we're waiting, I'm just going to ask one of you to see if you can press the raise hands button. Excellent, thank you, Sander. That's amazing. So what I will do is if you raise your hand, then you have the ability to pop a question into the chat, or you also have the ability for me to unmute you and for you to actually ask that question. Okay. Oh, marvellous, there's the chat. How do you raise your hand? Okay, thank you very much. I believe that you click on the three little dots and you should see a little raise hand icon. Okay, although that said, I can't see it. So Xander, would you mind popping into the chat the button that you press to raise your hand? Okay, and I think what we will then do is we are going to assume that a few people are late, so we will just carry on. Okay, and they can just join in. Oh, there we go. Participants, raise hand. Okay. Yeah, so click on more and then you can raise your hand. Right. Okay. Let's get going. So what I will do, I should see things popping up as we go. Okay, so one thing you'll be able to see at the top, I am using a new Microsoft piece of technology, which was only released recently, which is our subtitles. So these are being created in real time. I apologize if they are not perfect, but it is still in beta. Okay, so let's get going. Okay, so when we look at pseudocode, your algorithms in the exam will either be presented to you either using a flowchart or pseudocode. It is incredibly likely that for your A-level, it will be in pseudocode. They want you to be able to write pseudocode in a fluent fashion, and it must be language independent. It cannot now be Python-ish. Python-ish was acceptable at GCSE, But when you are doing your A-level languages, it has to be proper Python syntax. Okay, so there are certain specific algorithms that you need to be able to recognize, which are bubble sort. You need to be able to recognize, I'm just going to get this one right in my head, bubble sort, insertion sort, quick sort for the A2. You also need to look for linear search and also binary search. Okay, so if those pop up in your exam paper, you may be asked, what does this algorithm do? Other ones that we've seen have been also things like the algorithm for writing two's complement, and that allowed us to do things like adding in binary addition was another one that we saw recently, and they just gave you the algorithm and said, oh, and what does this do? Now how can you extend it? Okay, so things that you might want to make sure that you can see are your data types. So you need to be able to declare the correct type of data type. So you'll see, obviously, a string is always going to be a string. Same for a char. Sometimes in code we use int instead of integer. In pseudocode, it must be integer. For pseudocode, we use real instead of a float. Boolean will be exactly the same. Okay, sorry, I'm just aware of my subtitles looking very bizarre at the moment. Right. So where we have to declare our data types, we actually need to give them a name, then a colon, and then their data type. Okay, so if you are using Python, this isn't going to happen. Okay, so you wouldn't actually have to declare. Now, if you are writing this and you are writing this in code, that's slightly different. If you are writing in Python, you need to make sure that you have used a comment identifying this is declaration. Okay. So the next piece would be constructs. So I'm going to get somebody to raise their hand, please, and tell me, what is a construct? Okay, I don't mind if you guess. Ooh, no one. Okay, so a construct is a set of statements which are put into a particular block of code. So if you imagine we are constructing our code, and for these ones, I've given you some examples. An if statement is a construct. It is a construction of a specific type of block of code. So here we have got an input from our user. We then create an if statement, and the if statement is the construct. Okay, so our construct is if my var does not equal Dave, then output not Dave. Notice over here, and I'm just going to grab my pen. With my pen over here, I shall use my laser pointer. There we go. Over here, you can see you've got a less than, more than sign. And that less than, more than sign means does not equal. If you are programming in Pascal, this should be really obvious because you would have used less than, more than. Python, VB, C#, not the same. We use the exclamation mark equals. Okay, so remember pseudocode less than, more than. Okay, else if, and the other thing that you'll notice, we have an end if. Okay, you don't necessarily have to put in our indentation. The indentation is there to make it easier to read. If you put that into your exam, it means that your examiner will find this easier to read if you make it easier to read, they won't miss marks. We're not saying that they would miss marks easily, but if you're hiding things, it makes it more difficult for them, especially when you give them huge paper long lines of code. Okay. Let's get rid of the pen. Oh no, I can't click. Right, next bit. Next construct, a loop. I've got a while loop. Again, we're using this thing over here, does not equal. And then we are then putting an input in at the end. Could somebody please raise their hand for me and let me know why we have taken in an input inside the while loop? So this is validation. Osama, brilliant, thank you. I'm going to unmute you if I can. Okay, brilliant. Osama, can you, oh no, unmute yourself, thank you.
Okay.
Could you tell me,
It's so that the value of my var can change within the while loop, because if you go in the while loop and then you can't change the value of my var, it's just an infinite loop.
Perfect.
This way you have a way to get out of it.
Marvelous, thank you very much. Yeah, you're absolutely right. It means if we don't take in the input, we cannot then stop the loop from happening. So if we don't reassign my var, we end up with an infinite loop, and that is a perfect explanation. Thank you very much. Okay. For loop, slightly different to the way that we are used to writing these, especially if you are not using C#. Here we have to assign the value of 0 to my num, and we say it goes up to the value of 10. If we were writing this in Python, can someone raise their hand? What value would we put instead of 10? Osama, can you tell us?
You'd put the number 9.
Oh, we go up higher.
Oh wait, 11. It would
Yes.
have to go to 11 because it stops before 10.
Yeah.
So it would anyway.
Absolutely. So Python requires us to put the maximum value plus 1, whereas other languages would require us to put the maximum value. Excellent. Thank you very much. Okay. So I've put a little link down here, which is to the OCR pseudocode guide. Now, no matter which exam board you are using, this guide is incredibly useful. This will take you through assignment. It will take you through your constructors. It will take you through classes, objects, also functions and procedures. So really, really very useful. That last one I mentioned, subroutines. We need to be very aware of how they will be written in pseudocode. So if you have a procedure, you will have procedure, name, and then this bit in the brackets. Really, we would only see this if we are writing in C# or Pascal. We have the name of your parameter, and then its data type. And you would need to make sure that you do that in your pseudocode. You need to make sure inside my parameters, I'm using this particular parameter with this name, and then this parameter is of this data type. Okay. Procedures and functions are written in a very similar manner. You just put the words procedure or function, even though our function has a return value, which technically ends the function, you still have to write end function. And that is because you then run the risk of appearing to have other statements inside the scope of your function. Okay. Oop. Right, so we're going to move on to modular code. We are a quarter of an hour in, so we're going to try and rush through the next little bit. This bit, actually, there isn't an awful lot that you need to be aware of, but there are specific things that you need to be able to say in the exam that relates to them. So we know that our modular code relates to abstractions. So we are taking our main program and we are blocking it, essentially. Do remember that a module is not a subroutine. Okay, it is very easy to say, oh well, a modular code is just abstracting into functions and procedures, but it's not. A module is an actual file which contains multiple subroutines, which means that you've probably used them already. Can somebody raise their hand, please? Tell me a library file or a module that you have imported in one of your pieces of code. Osama?
Random.
Oh, yes, you've imported random. Yes. What did random do?
It let you generate random numbers for the most part.
It did, yeah. In its most basic concept, it allowed you to generate random numbers.
You can select random items from a list or random number within range.
Mm-hmm. Yeah, so a random number within a range, a random number in a list. So the random module contains a number of different functions that we can call on. Okay, anyone else want to give us an example? Sander, can I call on you?
Sorry, I can't think of anything at the moment.
Okay, no problem. So when we are calling library files, I gave sysutils as an example. We could call math, which allows us to do things like rounding and square roots. There are loads of these different files that we can pull in. And the thing that you will be asked is, firstly, what is a module? And also, why are they beneficial? So just take a couple of seconds, have a think. If I have pre-written, and that's the important bit, pre-written functions in a file, which as a team of coders we can all use, what are the benefits? Take 30 seconds to write one of those benefits down for me. Okay, right, so I've got some chat. Right, so the question was, what are the benefits of using modular code? Okay, so I've got makes working on code as a team easier. Yep. It's time efficient. Excellent. Yeah. Essentially, your benefits of modular code would be it's pre-written. So therefore it's tested, it's pre-tested. Easier to test because there's less code to test. It's more time efficient because you are coding less stuff. And in this case, also easier to debug because what we are doing at this point is we are being told if there is an error, this is where the error is. Okay. We've also got lots of stuff about teamwork. So if you are using the same one across all of your different teams, you know which code they're going to be using. So if you say, I want everybody to find a random number, we know they're going to use the random library and it's random.randint. Okay. Again, I'm going to identify what we have here. Okay, so in your exam, you will be given a list of assembly language instructions. Sorry, I'm just sending this link to a student who is having issues logging in. You're going to be given the list of your assembly language. You will be given a set of questions which relate. Okay, so here it's not dissimilar to writing basic code. In your high level languages, you have if statements, which in this case are branches. If you you may have jump statements. Now, jump statements are quite old. So it's unlikely they would be in your high level language. And if they are, please don't have them in there. But one statement in a high level language equates to many assembly language because it is, well, it's a lower level. So therefore it's more basic. Why, and I'm going to ask again for you to raise your hand, why would you be given these actual instructions in the exam paper rather than assuming that you know them? Sander?
Maybe because in real life you'd get them as well.
Yes. Yep, you're absolutely right. In real life, you would definitely probably look these up. The reason specifically is because you cannot assume that these instructions would be used for every single CPU. Every CPU has a different set of instructions. So if you remember our lessons when we were talking about internal hardware, low-level languages are programmed specific to that particular CPU. Okay, so in this case, you are given a lovely table of your assembly instructions, and then you have to answer questions on them. Okay, but the logic will be the same. Okay, things to look out for is that some of the questions will try and trip you up with mentions of specific memory locations. Hello, Kiara. And some of them will be giving you questions asking you to use either memory or direct data. Okay, now that means that you would be talking about direct addressing or immediate addressing. Okay, so just like the last slide, I've given you a link down here. I will send you these slides so you can click on the link. But this particular one is a PDF which gives you all of the instructions that may well be given to you in your actual exam. It's definitely worth knowing the majority of them because it makes it quicker. Okay, but you will be given a copy. Right. So moving on, I'm going to add in some exam questions at this point. So grab a pen and paper and have a go, and then I will talk you through the answer. So things to be aware of. Okay, so if we are looking at here, so I'm just going to get rid of my laser pointer and add some highlighting. So here, the purpose of the code is to count to 1 to 10. Okay, so if I'm saying it's counting to 1 to 10 inclusive, oh, that's not very helpful at all. Let's grab a highlighter instead. And then writing the values to memory location 17. So really specifically, we need to make sure that we're writing to the right location. Now, we have R0. So here they've actually told us what to use. Okay, so we've got R0, we've got a hash in there, and we've also got a 17. Okay, now remember that we are using direct addressing and immediate addressing. Okay, if anybody has an answer, would you like to raise your hand? Okay, and for the benefit of Kiara, who just joined us, if you press the 3 dots, you should be able to raise your hand. Okay, I'm going going to give you a couple of minutes to finish. Okay, right. So does anybody have an answer that they want to put forward? Okay, so for this one, initially what we would do is we would use the add. Okay, now add, we've got R0, R0, and then #1. The R0 is the reference to the location. Okay, and we knew that that was being used because it had mov R0 and str R0, 17. Okay, now str, if we look over here, is store that value in this particular location. R0 for the first time is use this number. Then the second time is where to store it. Hash means that we are using immediate addressing. So we are using the number 1, not the memory location 1. Okay, so in this case, we are taking the value of R0, adding 1, then storing it again in R0. Then we want to know how to finish our loop. So here, CMP means compare. Okay, and we can see that here. We compare the value in R0 to the number 11. We know it's the number 11 because there's a hash. We can then use BNE. BNE means branch, sorry, branch if not equal. Okay, so BNE, branch if not equal, and if it's not equal, this is what to do. So branch if not equal, go back to the beginning of start loop. Okay, and start loop is here. So we knew to use that. So if it was not equal, go back to the beginning of the loop. If the branch doesn't happen, we end the loop and we halt. Now you can see I've actually only written 3 lines. So the 4 marks over here aren't necessarily for 1 per line of code. The 4 marks were the adding, so adding 1, comparing, knowing to branch, and knowing where to branch to. Okay, so I've given you the second half of the table here. For 1 mark, R1 contains the decimal value 7. So we have an integer. So what value will be contained after the instruction below is executed? Have a look, 30 seconds, and raise your hand if you have the answer. Ooh, I can see answers in the chat. By raising your hand. Ah, right. So you should be able to click on the 3 little buttons. If you click on the participants, there's a raise hand button. Oh, lovely. And Alt and Y is a shortcut to raise your hand. Thank you very much, Osama. But yes, you go to participants. Okay, so does anybody have an answer? Osama,
I got 60.
you got 60. Okay. Oh. Okay, and now my answer is different to yours. So, what does LSL do? Okay. You can pop this in the chat if you don't want to speak out loud. Okay, so if we look over here, oh, I see a chat. Shifts the binary 2 to the left. Thank you very much. Yes, so it shifts the binary number 2 to the left. So here, what we have, LSL, logically shift left. We take our 7 in binary, we shift it 2 to the left, and we put in trailing zeros. And what you'll see in my answer down here is that you've got a 10, and you've also got a 2. The 10, because it's subscript, stands for in base 10. So 28 in base 10, or in base 2, 11100. If you put in the leading zeros, that's absolutely fine. Okay, so we talked about direct addressing and immediate addressing in the last slide. Can somebody tell me what is the difference? And it's only 1 mark, so quick, short answers, please. Okay, anybody have an answer? Right, okay. So when we were talking about immediate and direct addressing, what we meant is that direct addressing means that the operand is the memory. So remember, operand is the data, okay? The operator is what's actually happening, so the instruction. So here, the operand is the memory address or register. Immediate addressing, which is the one with the hash, means that the operand is the actual data. You may see that they use the word datum. Okay. Oh, hello, Jessica. Thank you for joining us. So I'll just go back over that. So here, the LSL is to shift, and direct addressing means that the operand, which is the data, is pointing to the address, the register number. So the operand is stored in this location, whereas immediate addressing, which is where we have the hash, is the actual data. So here, where we have passed our hash 2, that is the actual number 2 rather than the memory location 2. Okay, so remember that when we talk about coding, direct addressing and immediate addressing is very similar to when we talk about passing by value and passing by reference. If we pass by value, we are passing into our subroutine the actual value, so like immediate addressing. And if we pass by reference, that's similar to our direct addressing because we are directing them to the memory location. Right, so another piece of our exam paper. Now this one relates to what we were doing before, but is more to do with our stored program concept. So remember that our low-level language exam questions may well be linked to how the CPU works. Okay, so I've already given you this as an answer. So the second 4 bits of the instruction here, what did we call them? Okay, so raise your hand if you have an answer. Ooh, okay. So we called that the operand. Okay, so the second 4 bits of our contents up here, you can see up there, that is the operand. The first bit is the operator. Sander, did you raise your hand?
Sorry, I was just testing out the OY thing.
Okay, no problem at all. Okay, so the second bit is to complete the table. Okay, now remember, this is to do with the fetch, decode, execute cycle. And lots of things that I've been saying to a lot of you is to read the question carefully. Okay, now reading the question carefully means that we are going to be looking at this one and say, okay, so the following registers, it's fair enough. But what are the values going to be when we are doing the fetch part of the fetch execute cycle? So we have completed it, and what values would we have? Okay, so just take 30 seconds to write this down, and then I'm going to ask people to pop some answers into the chat for me. Okay, so does anybody have any answers for me? Ooh. Okay, so we've been given all of our information on the left. We know that we have our memory address. Okay, and we have what the opcodes mean. So down there, remember operand and opcode. The opcode is the first 4, so that's what it should do. The operand is the data that it's working with. So the first one here, PC, should be at 0010. How do we know that the PC should be pointing now to instruction number 2? Kasana.
It was at 0001 at the start.
Mhm.
So it increments, so 0010.
Lovely. Yeah. So once it has fetched the PC, then increments by 1, which means it was at 1, and we knew that because it was up here. And now it's 2. Super. That would have been 1 mark. And the next one would be the memory address register, the MAR. Does anybody have a value for the MAR? Okay. Ooh. 0001. Okay. I love the question mark at the end. You're absolutely right. It is 0001. Perfect. Well done. So the MAR gets the value. Okay. What it was doing is it was initially here. Here is the next one. So the MBR. Now the MBR is interesting in as much as the exam boards may use one of two names. Here we have called it the memory buffer register. It could also be the memory data register. So MBR and MBR and MDR are one and the same thing. But in this case, they've called it the MBR, which is memory buffer register. So what it's doing, the MBR is getting, so it's fetching the thing that it found at the correct location. So here, it's gone to 0001 here, and it's got the data. So MAR here held what was in the PC originally. The PC was incremented, and the MBR takes the value of what it's found in where the MAR is pointing to. Okay, now I know I'm going slowly, but I'm just aware that my poor subtitles are trying to do this in real time and aren't catching up. Okay, so let's carry on. So we would want to describe what is happening in the decode and execute. So we've done the fetch, and again, reading the question carefully, decode and execute. Now I'm going to go through these answers a little bit quicker because I want to also go through the other parts. So here we have 3 marks, and you only need to have stated 3 of one of these 6 bullet points. So knowing the instruction is held in the CIR, potentially saying that the result is stored in the accumulator because that's part of the execute. And the last one, which is not as obvious, so knowing at the end if a jump or a branch happens, then the PC is updated, it doesn't just increment. Okay, very, very quickly, what would be the outcome of executing the instruction just here? So 0, 1, 0, 0, and then the operand of 0, 0, 1, 1. So I'm just going to highlight this. Osama.
It would store the accumulator's value in this here, in the memory address 0011, which is like completely blank currently.
Okay.
So whatever accumulator will go there.
Yeah. So here we're saying the current value of the accumulator would be stored in memory. That's absolutely fine. Remember, it's only 1 mark, so we don't have to go into huge amounts of detail. If you said the value of 001, which is binary, or 3 would be stored in memory, that's equally okay. Okay, so we're going to move over to networks and transmission. So this covers a huge, huge amount. And I've noticed that previously where we spoke about LAN, so local area network, and WAN, which is wide area network, so more than 2 LANs connected, they've added 2 newer terms. So PAN is your personal area network, which is where, so I'm working on my laptop and I might use my phone and connect the 2 together. So my phone may have a personal hotspot, so a Wi-Fi hotspot. And then a MAN, which is a metropolitan area network. And that's where a network is set up across an entire city or an entire town. One that I use in the UK is Norwich, which has citywide Wi-Fi. And anybody can connect. So sometimes you would have an open network, other times would be closed. And they tend to talk about closed networks a lot more often to do with security. Okay, so we're going to go right back to the real basics. So we can communicate using parallel and serial, and we know that parallel sends transmissions many bits at the same time, so quite literally in parallel. So if you look at these things on the left-hand side, we have an example of a parallel, I want to say wire, it's not right, it's a cable, and a serial cable at the top, so one after the other. But why would serial transmission be preferred to parallel? because parallel is quicker. Okay, I have an answer. The data will always be in order. That's lovely. Yes. So serial communication will make sure that the data is always received in the correct order. Lovely. Yep. That would be one of our 4 marks. We might want to expand on that. So remember, we're only being asked to describe 2 reasons. So we would explain why, but that would certainly be half of the answer. Can anyone else add into chat for me or raise your hand for a second one? Ooh. I'm surprised because this came up in the GCSE. So in this case, parallel uses more wires. Okay, so because it uses more wires, it's more difficult to code for, it's more expensive, and it's difficult to repeat. So when we mean repeat, we mean when you get to the point where the data is below where we can transfer it at a proper speed, we can't then boost the signal easily. We can, but it's not easy. Just like Chiara said, parallel needs to be synchronized. Because our serial transmission is in order, our parallel is not in order, so therefore there's more chance of errors. And in order to keep it synchronized, we have to limit the speed, and we have to limit the cable length. So serial works over greater distances. The other thing that we would want to pick up on here is because parallel cables have more than one wire, and generally they use copper cabling, there is a risk of crosstalk. Crosstalk is the technical term for when the communication is interfering with the other wires. And what happens is that the data from one wire corrupts the data from another. Okay, and that's to do with the issues of sending communication up and down copper wires. So another higher chance of error. Okay, so in the context of networking, and I'm going to ask you to, again, raise your hand or type it to the chat. Tell me, what is bitrate, please? Hello, Ollie. Right, okay, Osama, you raised your hand. What is bitrate?
Bitrate is the speed at which you can transfer bits down a wire or connection.
Yeah, absolutely. And I've got from Jessica here the rate at which a bit of data can be transferred. You're both very, very close. Yep, so the number of bits that can be transferred or sent or received, either one of those words is fine, in a second. Okay, and we use the word in a second because bit rate is measured per second. Xander, that was absolutely perfect. Well done. Okay, so if we know that bit rate is the number of bits that can be transferred or received per second, what is latency? Oh, not so many messages this time. Osama.
Latency is the amount of time it takes to get from your device to wherever you're wherever you're sending it and back.
Yes, yes. So I've given you a clue here in terms of the little diagram. When we are looking at latency, it's the delay between the signal being sent and the effect being noticed, or the signal being transmitted and arriving. So if you are doing something which is online, which we are today, this would be, so you can see my, my subtitles at the top. Small amounts of data, so voice data is being sent to a server. what's happening is they are then being translated into text, and then they are appearing on my screen. So the slower that these appear on the screen, the more latency we have. So it's going off to a server and coming back. Fabulous stuff. Okay, so here, a school has installed a wireless network. Okay, so we're talking about wireless access points. Okay, and in this case, multiple wireless access points. And when you're in your exam, please do take some highlighters, highlight that paper. Okay, what hardware component is needed for the device to be connected to our wireless network? Okay, Osama.
And Mac, what's it called? A network.
Oh,
I can't
yeah,
remember.
no, you're right. Keep going.
NIC. It was network interface card.
Well
network.
done. Yeah.
Yeah.
Yeah, a network interface card. Okay, so all devices would need to have some form of network interface card in order to connect to a wireless access point, or in fact any network. So in order to connect, you would have normally a wireless network interface card for a mobile device, or you may find that you have a plug, so you have your network plugs, so that would allow you to actually cable connect. In our case, we're talking about wireless though. Okay, whereabouts on this diagram would we connect our cables to the network? So let's look at our segment up the top here. Which device are we physically plugging into? C. Okay, so C over here is going to be this particular machine. Okay, so imagine we followed this cable. And that cable is going to go into, perfect, the router. Yeah, so the router is going to, instead of our wireless access point, is going to hold the physical connection to this particular network. Okay, so on this one, a student is going to try and use their own mobile device. So again, if we are going to highlight this, we would want to say, so it's their own mobile device, doesn't belong to the school. He knows the correct SSID, so we need to know what that stands for, and we need to know what this is. So WPA key for the school network. Okay, but he's still not able to connect to the wireless network. So sometimes if you connect in, you may have to log in. So he's used his SSID, he's used his password, which is what the WPA2 key is. But they might have put something else in place that stops him from logging in. What could that be? The server could check. Oh, Kiara, perfect. Yeah. So Kiara has said to us the server could check the device's MAC address. Now, that would get you 1 mark. If we want to extend that to 3 marks, what we would want to do is to extend. Now, the MAC address in this case is being checked against a white filter. So if we remember when we were talking about our proxy servers having a blacklist and a whitelist, a blacklist picks people out and says, you personally cannot be connected to. A whitelist blocks everything and then allows specific sites to be accessed. Well, this is the same thing. A MAC address white filter blocks all devices, but only allows specific devices to connect. So in this case, the wireless access point will hold a list of authorized devices. If you are not authorized, even if you have the password, you will be rejected. Okay, so we need to know the difference also between our IP address, because they won't have one at this point, and a MAC address. Can somebody tell me what a MAC address is? Ollie, can you unmute yourself and tell us? And if you don't want to unmute yourself, you can add in something to the chat. Okay, you are definitely unmuted, but I don't think we can hear you. So if you want to open up the chat and add in your answer. That should be popping up as orange on your screen. Okay, does anybody else know what a MAC address is? Media access control, lovely. Yep, so MAC address, specific address, lovely. It is your address specific to the NIC. Yeah, lovely. Yeah, media access control address is your MAC address. And what we're looking for there is it's the one that is unique to the device, or specifically unique to the NIC. On this one, you cannot change it. Your IP address is logical, so therefore it is changeable. Your MAC address is physical, and therefore not changeable. So you can block people on their specific MAC address. It is difficult to block them on their IP address because the IP can change. Okay, we are nearly there, people. Right, so we have on the left-hand side a identifier for a wireless network. So remember, we're still talking about wireless. We can see a MAC address down here. We can see an IPv4. So this is the IP address that we would be looking at when we talk about IP addresses in the exam. You do have an IPv6, which is where we save these as, oh, tell me, what kind of data is it? Because they're not integers. Okay, they are, it's not a string. There is, brilliant, thank you, Jess. It is hexadecimal. And you know it's hexadecimal because you don't see any letters higher than F. So yeah, our IPv6 is saved as hexadecimal. What's the role of our SSID? So our SSID is up here at the top. But what's the role of it? It's the name of the wireless connection. You're absolutely right. I can get that to appear. There we go. The SSID is called the unique identifier for the wireless network. It is the name of the wireless connection. And the second mark there is that the client has to use the same SSID in order to join. So when you are looking for wireless networks on your phone, you will see a list of what you see as the name of the network, but actually the name of the network is its SSID. So we use WPA2. It's an example of a protocol. Okay, now in this case, I'm using a slightly different protocol. That's rather by the by. The question here is explain what is meant by the term protocol. Okay, does anybody know the standard definition for protocol? Jessica, would you like to unmute yourself? Ollie, I'll come back to your answer in a second. Okay. I don't think we can hear you, love. So do you want to type your answer into the chat? Ollie, you are correct. The structure or the shape of the network is the topology. And the subtitles picked that up. Okay, so the example of a protocol, the standard definition for a protocol is a set of rules that governs data transmission. Okay, for the second mark, allowing two devices to communicate. So what we want to know and what we want to put on our flashcards is that a protocol is a set of rules that governs data transmission between two or more devices. Okay, so that is just over the hour, but that's okay. We have covered pseudocode, assembly language, a little bit on architectures, network packets, and modular code. What I will do is to make sure that this whole video is uploaded, so I've recorded everything that we've done. That will go onto a YouTube link, which I will send to you. And I will also send everybody that has joined us a copy of the slides that I've used. Okay, thank you so much for everyone who appeared, no matter when you turned up, and I will see you all soon. See you later.